Good morning, all of you. In the previous class, we were dealing with the properties or the characteristics of acids and bases. We learned acids are sour in taste, bases are bitter in taste, acids contain H plus ions, bases contains OH minus ions, acids react with metals to form salt and hydrogen. Bases also react with metals to form salt and hydrogen. Then acids can react with carbonates and bicarbonates to form salt, water, and carbon dioxide. The next property, that is, acids react with bases to form salt and water. Let's see from there. Acid, for example, hydrochloric acid. Aqueous means in water. A solution of hydrogen chloride means hydrochloric acid, aqueous solution means this contains H plus and Cl minus ions plus NaOH. Aqueous. Aqueous means in water. So here in water it gives Na plus and OH minus ions. What we get? Salt and water. What is the salt? NaCl, this is the salt, and water, H2O. NaCl, it is in the soluble format because in presence of this water, NaCl, you will not be able to see this salt. It will be in the dissolved state. So we are writing aqueous solution, and that water in the liquid format. So acid plus base or base plus acid gives salt and water. Now, reaction of metallic oxide with acids. Reaction of metallic oxides with metallic oxide means basic. So with acid we have to write metallic oxide, metals, FeO, CaO, Na2O, like that. These are metallic oxides. Metallic oxides are basic in nature, means when they are dissolved in water, you will be getting a base. For example, calcium oxide. Calcium oxide, when dissolved in water, you get calcium hydroxide. Sodium oxide, when dissolved in water, this is metallic oxide. Metallic oxides are basic in nature. When the sodium oxide, when dissolved in water, you will be getting sodium hydroxide. After dissolution, we call it as alkali. After dissolution, we call it as alkali. Soluble bases are called alkali. So, generally, we say metallic oxides are basic in nature. Then, when this metallic oxide is treated with acid, you will be getting salt and water. Base plus acid plus base gives salt and water. So take small amount of copper oxide, that is CuO, in a beaker and add dilute HCl. Dilute HCl. Slowly you add while stirring. Note the color of the solution. You will notice that the color of the solution becomes blue-green. And the copper oxide dissolves. CuO dissolves, means when you add this HCl, the color of the solution becomes blue-green. That is due to this blue-green color of the solution is due to the formation of CuCl2. During this reaction, CuCl2, this is the salt form plus water. So general reaction between a metallic oxide or metal oxide and an acid can be written as metal oxide or metal oxide, that is basic, plus acid. Similar to base plus acid gives salt and water. Salt plus water. What about the non-metallic base? So non-metallic oxide. Non-metallic oxide. Non-metallic non-metallic oxide, that is non-metallic oxides are acidic in nature, means when they are dissolved in water you will be getting an acid. Non-metallic oxides are acidic in nature, so this acid, when you react with a base, for example, carbon dioxide. Carbon dioxide is, carbon is a non-metal, so carbon dioxide is a non-metallic oxide. Non-metallic oxides are acidic in nature. When they are treated with, this is acidic, so you have to treat it with a base. So when it is treated with a base, that is calcium hydroxide, it is a base. You have seen this reaction, that is carbon dioxide when passed through lime water. Carbon dioxide when passed through lime water, what we got? Salt, that is calcium carbonate. Calcium carbonate we got. So, carbon dioxide when passed through lime water, this is acidic, this is basic, you will be getting salt and water. Calcium carbonate, salt and water. This reaction you have already seen. You saw the reaction between carbon dioxide and calcium hydroxide. Calcium hydroxide, which is a base, react with the carbon dioxide to produce salt and water. Since this is similar to the reaction between a base and an acid, we can conclude that non-metallic oxides are acidic in nature. Where is the non-metallic oxide here? See, carbon is a non-metal. This is a non-metallic oxide. Non-metallic oxides are acidic in nature. When you treat it with a base, you will be getting salt and water. Next topic we are moving to. Okay, before that, let's see some questions. Why should curd and sour substances not be kept in brass or aluminium vessels? Means we won't keep curd and as sour substances, means acidic substances, in brass vessel or aluminium vessel, means metal. We won't keep curd in metallic vessels. Why? Because this metal will be reacting with acid. Metal, this vessel will get spoiled. At the same time, this curd becomes toxic. So we should not keep sour substances, SOUR, sour substances in metals. Now next question, which gas is usually liberated when an acid reacts with a metal? Which gas is usually liberated when an acid reacts with a metal? You know that metal plus acid gives salt and hydrogen. So which gas is liberated? Hydrogen gas. Illustrate with an example. Illustrate with an example. We have seen one diagram for that. How will you test for the presence of this gas? What you have to do? That soap solution test, that soap solution, through soap solution you pass this hydrogen gas and you got the bubbles covered with a film of soap solution. And when we brought lighted candle to that bubbles, what happened? It burned with pop sound. So question is, how will you test for the presence of this gas? Bring a lighted candle to that bubbles, it will burn, it will burst with a pop sound. With a pop sound. Next question. This question I am reading from page number 22. Page number 22, there is a box in which questions are given. Next, metal compound A. One metal compound A reacts with dilute hydrochloric acid to produce effervescence, means brisk effervescence. Effervescence. Effervescence, I told you, when you open a Pepsi bottle or Coca Cola bottle or like that soft drink bottle, carbon dioxide rushes out, and we call that rushing out as effervescence. So many bubbles, globules will be coming through this solution. We call that brisk effervescence. Question I am reading once again. Metal compound A reacts with dilute hydrochloric acid to produce effervescence. The gas evolved extinguishes burning candle. That means that is an indication that is carbon dioxide. Gas evolved extinguishes a burning candle. Write a balanced equation for the reaction if one of the compound formed is calcium chloride. If one of the